Okay, here we have, this is number 5 from 8.2. And remember at 8.1 we were doing distribution of a sample mean, and now we're doing distribution of a sample proportion. Now we're told under specific conditions that the sample proportion is distributed normally about a mean that's the same as the actual proportion of the population. So when we're trying to describe the sampling distribution of the population proportion, of the sample proportion, I should say, we know we have a mean of 0.61, which all these have. The standard deviation is just given by a slightly different formula than we have from the mean. So it's just this formula right here. We just take the square root of p times the complement of p, right? 1 minus p divided by the sample size. Okay, so we just do that real quick, figure out what that is. Let's see, it's a square root. I think I have it in here. Let me just make sure. Yeah, our population proportion is 0.61. So this is the proportion times the complement of the proportion divided by 1,000. That's the sample size. And then we take the square root of the whole thing. And we get that the standard deviation is about 1.5%. And we just plug that, let's just take that over here. It looks like this is the right one. The other thing we have to do is do the checks to make sure it's normal and that the sample size is not too big. So the first one is to make sure that the sample size is not more than 5% of the population, and that's definitely true. If you take this and divide it by this, it's definitely less than 5% of 1,500,000. The other one is given by this formula. We just have to take the sample size, multiply it times the population proportion times the complement of the proportion, and make sure that that's greater than or equal to 10. Let's see if I have that one already. So it's 1,000 is the sample. Yeah, here it is. This is 1,000, that's the sample proportion, times the population proportion, times the complement of the population proportion. We just have to make sure this number ends up being bigger than 10. That guarantees that the sample proportions are distributed normally, and we can use the normal curve calculator in StatCrunch. Okay, so what do we say? The mean of the sample distribution is 0.61. We calculated the standard deviation as about 1.5%. Yeah, okay. So just copied and pasted that from Google. And then now we have our questions over here. The first is, what is the probability of obtaining 640 more individuals with a characteristic in a 1,000-person sample? The tough thing is you can't plug in 640 into the calculator because we've stated the random variable in terms of proportions. But what it means to have a 640 person with a characteristic out of 1,000 people is that we get the proportion 640 out of 1,000, or 64%. So we're really asking right there, what is the probability that we pull a 1,000-person sample and get a sample proportion of 64%? 64% or more, right? Yeah, or more. So all we have to do is change the inequality around and ask what's the probability of getting that 64% or more. Notice that's above the mean, so this should be pretty small. Yeah, about a 2% chance. I think we're rounding to 4 decimal places, so that's 0.0259. Let's see if that checks. Yeah, 0.0259. Okay. Now part C just is the same kind of thing. It's stating it slightly differently. We want to know what's the probability of getting 590 or fewer individuals with the characteristic. So again, you have to turn that into a proportion. 590 divided by 1,000 is just 59%, right? So we're asking it, what's the chance of getting less than 59% proportion? And that's, note that 59 is below the mean. Not crazy below the mean though. This should have a little bit higher chance. Yeah, and it's about, what, 9% chance. So 0.0974 would be the 4-digit approximation. Anyway, I hope that helps. The trickiest thing is just converting this people into an actual proportion before you throw it into the StatCrunch calculator.